Welcome back. This is Mr. Spinks, and we are in section 5.6. This is the second video of section 5.6. Tougher of the two, guys. Pay attention now. We're talking about all the rules for exponents. Try to look at this logically. Don't memorize. Memorizing never works, trust me. Starting off with the product rule. If we've got two things to the same base, you notice how A is the base on both of these, and we multiply them, we would add the exponents. Now try not to memorize that. Think about this logically. It works like this. If I have 5 squared is the same thing as 5 times 5. So that's that part. And let's say I multiply that times 5 to the third power, which is 5 times 5 times 5. Well, if you look here, what we really have is 1, 2, 3, 4, 5 5s out there. Okay, that's the same thing as adding the 2 and the 3 and getting 5 to the fifth power. So at that point in time, you would evaluate 5 to the fifth power. 5 times 5 times 5 times 5 times 5 times is 3,125. So that's the rule with product. Let's go to quotient. Quotient is division. Anytime you are dividing, it says subtract. I want you to think about this like weight, though. Trust me, it works a lot better. Kids get confused here. Let's say we had x to the 6th divided by x to the 2nd. X to the 6 is 6x's being multiplied together. X squared is 2x's being multiplied together. So what happens whenever you have the same thing on the top and bottom in a fraction is they cancel. So 2 of these upstairs will cancel the 2 downstairs. And when you do that, you look and you say, hey, there's how many are left? There's 4 x's left, and they're left upstairs. That makes that x to the 4th power. And when I play this game, I always ask students, where are there more x's, upstairs or down? Upstairs. How many more are there upstairs? There's 4 more. That's why x is to the 4th power, upstairs. Take, for example, a different example. You've got x to the 3rd divided by x to the 5th. Once again, x to the 3rd is 3x's being multiplied together, x times x times x. And x to the 5th power, that's 5 of them being multiplied together downstairs, or in the denominator. Same thing will happen when you have the same thing in the top and bottom of a fraction. They will cancel. So those 3 x's upstairs will cancel 3 of the x's downstairs. Oftentimes when I do this, kids say the answer is x squared. Well, no, it's not, because we marked out all these x's upstairs. And therefore, there's nothing actually upstairs. The 2 x's left are actually downstairs. When there's nothing upstairs, we write a 1. That's why x to the 3rd over x to the 5th is 1 over x squared. And notice there's 2 more x's downstairs. And if there's nothing upstairs, we always write a 1. That's our quotient rule. Be careful with that one. Moving on to zero exponent rule. This one's tough. Everybody thinks anything to the 0 power would be 0. No, it's 1. Yeah, I'm serious with you. 8 to the 0 power is absolutely 1. You disagree with me, write it in to plug it into your calculator and check. Anything to the 0 power is always 1. Next up is negative exponent rules. And here's how the way negative exponent rules. If you are a negative exponent and you are upstairs, you will physically be moved downstairs. That's why the a to the m went downstairs. Take, for example, x to the negative 2. X to the negative 2 is x to a negative power upstairs. What we do, we move that negative power from upstairs downstairs. So the x goes downstairs and its power goes from negative to positive at that point in time. You don't see anything upstairs, and just like in the previous problem up here, if there's nothing upstairs, you write a 1. X to the negative 2 is the same thing as 1 over x squared. Let's take one more example. 4 to the negative 3rd power, same thing. I will write a denominator, assume a denominator, and take this 4 to the negative 3, which is negative upstairs, downstairs. So the 4 to the negative 3rd power upstairs goes downstairs. The power becomes positive. There's nothing upstairs, so we write a 1. And then it's our job to evaluate what 4 to the 3rd power is. 4 to the 3rd power is 4 times 4 times 4, which is 64. Makes this result 1 over 64. The last one is the power rule. For the power rule, we always multiply the exponents with the power rule. So notice how here, when we take a power to a power, those powers are multiplied. Take, for example, 5x squared to the 3rd power. The 5 is going to be taken to the 3rd power and the x squared. is going to be taken to the third power. That's this third power being distributed to both parts right there. Now, right here, x squared to the third power, there's multiplication. 2 times 3 is 6. That's x to the sixth power. And you would evaluate 5 to the third power, which is 5 times 5 times 5, which is 125. 125x to the sixth is the answer for that one. Let me circle all the answers for you. So those are our basic rules, guys. Now let's use them in these examples. 2 to the second times 2 to the third, we would add the powers. 3 plus 2 is 5. This becomes 2 to the fifth power, which is 32. Next one, negative 3 squared times negative 3 to the fourth power. I will add the exponents. 2 plus 4 is 6. Becomes negative 3 to the sixth power, which is negative 3 multiplied by itself 6 times. Ends up being 243. Down here, it's 4 to the seventh divided by 4 to the fourth. I look and I say, where are there more 4s? I see 3 more 4s upstairs. So 3 4s will be left upstairs. There will be nothing downstairs. We assume that is a 1. And 4 to the third power, 4 times 4 times 4 is 64. Last one on this slide, 2 to the negative 4. I immediately assume a denominator of 1 and take that negative power downstairs. So 2 to the fourth power is downstairs because it was negative upstairs. When it moves down, it becomes positive. There's nothing upstairs. I always write a 1 when that happens, and then I evaluate 2 to the fourth power. 2 times 2 times 2 times 2 is 16. That's how I get 1 over 16 for my answer there. Next examples, 12 to the 0 power. Anything to the 0 power is always 1. Be careful here. The difference between negative 12 to the 0 power and negative 12 to the 0 power is very important. Negative 12 to the 0 power, this one over here, the negative 12 is taken to the 0 power. It's 1. But here, we talked about this last time, any negative without parentheses is like negative 1 times that. We would take the exponent first. 12 to the 0 is 1. And the negative 1 times that would be negative 1. This one right here is actually negative 1. Be careful there. Here I already took care of negative 12 to the 0 power. Everything is being taken to the 0 power. So it's 1. And here we have two things, 4 and x, all being taken to the 0 power. Since they are multiplied, we can distribute that 0 power inside and you get 4 to the 0 times x to the 0. Well, 4 to the 0 is 1, x to the 0 is 1, and the final answer is 1. 0 power is easy. You just got to be careful with that. All right, last ones. Last ones we're talking about here, we're going to play the same game on. 4 to the first times 4 to the second. Well, we're multiplying the same base together. We will add the exponents. Becomes 4 to the third power, which is 4 times 4 times 4, which is 64. Be careful on this one. This one's tricky. Everyone would look here and say, hey, the answer is 0. It's negative 7x to the 0, but there's no parentheses. It's like negative 7 times x to the 0. Once again, in order of operations, please excuse my dear Aunt Sally, the exponents come before the multiplication. That's why you take your x to the 0 and get 1 before you multiply negative 7 times it. The answer here is negative 7. Be careful on those. On to the bottom, 6 to the fourth over 6 to the second. I look, I see division. I notice there are more 6s upstairs. In fact, there are 2 more 6s upstairs. So I will be left with 6 squared, or 2 6s upstairs. That's 36. Last one, negative 8 to the negative 2. Be careful. There are parentheses. Therefore, this entire negative 8 will be dragged downstairs, since the exponent is negative. Now, the negative on the 8 doesn't change. That's the base here. The power, the negative 2, will turn positive. And there's nothing upstairs, so we write a 1. Last step is to evaluate. Negative 8 squared is 64. And the 1 will stay upstairs. Final answer is 1 over 64.